Minimal APIs are a new feature in .NET 6, and we are in the process of exploring them. In this two-part series, we're building a complete application that consists of a SQL database, a data access layer using Dapper, and a minimal API in the front end. This is part 2, where we wire up our minimal API for full CRUD access. If you missed part 1, go back and check it out. Now, if this is the first video you've watched of mine, my name is Tim Corey, and it's my goal to make learning C# easier. I provide videos at least twice a week here on YouTube to help you grow as a developer. I also have a full set of training courses on IamTimCorey.com. I encourage you to check out all the resources that I have to offer. Now, in this video, as with most of my videos, I'm going to create some source code. If you'd like a copy of the source code, use the link in the description. Okay, let's go over to our code and get started. Now, just a quick recap where we're at. Again, if you haven't watched part 1, please do, because otherwise you'll get a little bit lost as to what we have in place. But let's go over it real quick. We have our SQL database, which we use a SQL database project to build. That way it's in Visual Studio, it's in source control if we put this under source control. I don't have source control applied to it, but you can. And we have our one table. We have our 5 store procedures for the full CRUD access. Again, if you don't know, CRUD stands for create, read, update, and delete. It's the major actions you perform against a database, whether it's getting data out or putting data in. Now we have a deployment set up in case we want to publish this repeatedly. We've already published it once, and that's in our SQL Server Object Explorer right here, minimal API user database. And we have some standard sample data in there right now that just has a few records in it. So if you go to tables, user, and say view data, you'll see we have 4 records here, Tim, Sue, John, and Mary. And that's just so we have something to work with when we first launch our API. Now we also have a editor config here, and the primary reason for this existing is so that we can use the file scoped namespaces, which is a new format as opposed to the block scoped namespaces, which would be the traditional way of using namespaces. So you can add more of your own styling here if you like, and that will apply just to this solution. We also have a class library called data access, where we have our SQL data access. This is where Dapper talks to our SQL database. And it really is fairly simple in the fact that there is our really 1 line, maybe 2 lines we consider or count connecting to the SQL database. There's our 2 lines of code necessary to talk to the database and get back data in a set of models. And here is our 2 lines of code to store data in SQL. And that includes using parameters. I had a question earlier about that. Yes, that includes sending parameters to our SQL so that we can insert things like first and last name or update a record based upon its ID and so on. So that's our save and load data method. We use this in our user data class where we say, hey, get users, get a single user, insert 1 user, update a user, and also delete a user. This class is what we'll be calling inside of our API. Actually using the interface for this class. So we'll have these 5 methods available to us in our API, which should make things rather simple when it comes to making the calls. Okay, so that's where we're at. We can collapse down all of this, and now we're down just to our main project, which is the one that's set as startup project. If yours isn't set as startup, just right click on it and say set as startup project. But this is our API. Let's close all tabs here. That way it doesn't keep opening back up. This is our API. And our API has very little in it to begin with because it's a minimal API. In fact, we have primarily 2 things, appsettings.json and program.cs. That's it for our API. We're going to add a little bit more to it and make it actually functional, but Even in a demo state, it will work right out of the gate. But first, let's do this. Let's go over to our SQL Server Object Explorer, select our database, and then go over to Properties. And in Properties, if we expand this out a little bit, we'll see that the connection string right here, if we double click and copy this, that's the connection string to this specific database. Now, I'll leave this in my code, but for you, it may be a different connection string. So don't just use my connection string. Do the same thing I just did. Select the database, then go to Properties, and copy that connection string. That's your connection string then on your computer for your database. So put a comma after allowed hosts in my appsettings.json file, and quotes say connection strings. And in here, I'm going to say default. Remember, that's the default value we're going to use, and that's going to paste in my connection string. So when we ask for the default connection string, it's going to give us back this string, which is a lot of stuff in here. Really, you could have a simpler connection string if you didn't want to specify subnet or multi-subnet failover, an application intent, and so on. But by copying and pasting it, it's really easy, and it gives us all we need and more. So whenever we refer to the default connection string now, we'll get this back, which, by the way, if we go back over here to SQL Data Access and look, the connection string ID, the default value is default. So when we're asking for a connection string right here, we pass in the connection ID, which is this parameter. But if you don't pass anything in for it, which we're not, then it defaults to default, which will get this connection string because that's where that name is. If we called this, I don't know, SQL DB, then we have to either pass that in to our calls to load and save data or change the default here to SQL DB. So just want to be clear on how that all works. So we have our connection string now. Now we can talk to our database. Let's close both of these out. We can minimize this again and look at our program.cs. Now, this comes with some standard boilerplate template goodness just to show off what you can do with your API. So if you look down here, first of all, this is collapsed. This is a new feature of .NET 6, which is it's collapsed the startup.cs and the program.cs into one file. It's also using that top level file where we don't see a static void main, we don't see the namespace wrapping, we don't see using statements. This is all essentially this file, program.cs, is the startup file, and everything in here is in a hidden static void main. In fact, it's a static async task main, so you can do asynchronous tasks in here. But it's all hidden. It's just it's assumed because of the fact that it's our starting point for every application. Therefore, we don't have to specify that if we don't want to. So with this all being in that one method, this is going to configure our web application. We're going to add dependency injection. We're going to build out our app to start so that we can access our configuration information. Then we're going to check to see if we're in development mode. And if so, we're going to use Swagger and Swagger UI. And that's that open API. That's the idea that when we launch this application, and let's just do it right now because why not? So we'll say launch minimal API, which is going to launch Kestrel as our web server. And then it's going to launch the browser with our API. Once it does, and it seems to have popped up underneath here, but there we go. This is our Swagger. So by default, we go to Swagger page, which notice the URL, if we can't see that, let's zoom in here. Localhost, note that now Kestrel and .NET 6, or actually it's in Visual Studio 2022, I believe, it changes the port number for Kestrel to be a randomized port inside of a range in the 7,000 range. So that's instead of being 5000 and 5001, which it used to be for .NET 5 and below. So I think it's both a .NET 6 and a Visual Studio change. I'm not positive. But anyways, it has changed. How about that? And then we do /swagger and /index.html. This is a default starting point for our APIs so that we can visually see the structure of our API and even test what's going on. So you can say, click on Get Weather Forecast and say, try it out, and just execute since there's no parameters. And notice that down here, it has returned a whole bunch of data to us in the response body with a code of 200, meaning success. So that's the API actually running. Now that's running with test stuff. We're going to get rid of that. Now that's Swagger. I show you that. We have HTTPS redirection, which means that we're going to not allow the user to say HTTP for our site. If they do, it's going to redirect them to the HTTPS version of a site. We always want that on. Now here's where our test data starts. We have some test data here in an array, and then we have app.mapGet. And what this is our API endpoint. So instead of having a controller that has then our information in it, we have this idea of an endpoint. And the difference between a controller and endpoint, a controller has the full information for a set of endpoints, essentially, or a set of places you can call. Whereas this is saying, hey, map get, which means this is gonna be a get call, and I want you to map out this specific path. And so if you type in your localhost : whatever the port number was / weather forecast, you will call this endpoint. And it will return forecast, which is a enumerable of 5 elements, and it's going to create just randomized weather. So we're going to get rid of that. That is sample code, as is this summary section here. So we'll get rid of that. And we also don't need now this internal record, the weather forecast, get rid of that. So now we've gotten rid of all of our sample code, but we're not gonna have anything then to run with our API. That's where we're going to start adding things back in. The first thing we'll add in is a dependency. So right click on dependencies and say add project reference. And we're gonna select the data access library. And now we can talk to that data access library. To do that, we're going to say builder.services, not add the MVC. We're going to say .services.add singleton. And we'll say SQL data access, control dot to add a using, and then SQL data access like so. And then we'll say builder.services.add singleton for user data and user data, control dot to add that using statement, and then like so. So it's going to add 2 things to our dependency injection system. First of all, our iSQL data access, and then second of all, our iUser data. We're going to use user data to talk to our data, but we need to have this in our dependency injection system, our iSQL data access, because it needs to be injected with our iConfiguration, and the user data needs to know about it because it uses iSQL data access. So those 2 entries need to be in our data access system. Now, right now, we have not used any global usings. And this might be a place to start using them because of the fact that we'll have to use the data access.data pretty much everywhere because it's something that's going to be, we're going to have access to iUser data. I don't think we'll need iSQL data access anywhere else. So we'll leave that one alone. But data access.data we will, and data access.models since we're getting back that user model. So we could put the global using here. We could just say global using like that and leave it here. But I'm not a huge fan of putting it in program.cs because of the fact that we're now adding one more thing to program.cs and it's getting pretty packed. I really kind of like program.cs to be a little less packed. In fact, I kind of liked the startup.cs idea better, but no one asked me. So what I'm going to do is I'm going to create a new file in my project. So add new class, and the convention is still forming on this. I kind of prefer usings.cs. Some people prefer global usings.cs. I'm going to do global usings.cs because I've seen that preference a couple of times now, but I kind of prefer usings.cs. So again, if anyone's asking for my vote, I vote usings.cs. It's a little simpler, but global usings.cs, and we're going to take away the namespace and the class, take away everything. And then we're going to grab this global using, we'll cut it out here, and we'll put it over here. Now, what does this do for us? Well, now we have access to iUser data without having to add a using at the top of the file. So if we didn't have this, let's comment it out real quick, then this right here would throw an error. See, it's saying, hey, I can't find that. But now we can have it accessible for every place that we need it in our application, not just this file. Since we're going to use it all over our application, that makes sense. Don't abuse the global usings, but it is something you can take advantage of when necessary. So I'm going to take another one, global using data access.data, not SQL client, data access models. There we go. Now, right now it's not being used, and it's intelligent enough to know that, but we will need that shortly. So I'm going to add that now so that we're ready to go. And with that, we are almost done. The only thing we have left to do is our actual API endpoints. Now, I could put them right here on line 23, and you'll see a lot of demos do that. I'm not a huge fan of that, but again, because we're getting program.cs to do pretty much everything. Remember that this is a method. It's one method, and its job is now multi-part. Its job is to launch the builder. Its job is to register services. Its job is to build the application. Its job is to add Swagger if it's in development mode. Its job is to handle HTTPS redirection. Its job is to run the application. And if you use the defaults, its job is also to configure all the endpoints with all of their methods. I think that's too much. So I am going to separate this out into a separate method. I'm going to move this into, let's create a file called APIs. All right, so APIs, or just API, how about that? Now, if you're going to have multiple of these, then you might want to consider doing something simpler like having one per grouping of endpoints. But again, if you get too far down this rabbit hole, then maybe you got a more complex API which would require controllers as opposed to just endpoints. But we're trying to keep a minimal API, so we have just one class called public class API. I'm actually going to make it a public static class, and that way we can reference it in our program.cs, and I'll show you how to do that in a minute. But with this, I am going to create a public static void configure API, and we'll pass in this web application app. Now, Why am I making this method and what is it going to do? Well, this is where I'm going to do all of my mapping. Okay, is in this section, which then allows me to come back to my program.cs. And I'm going to say app dot, and then the name was, configure API. So I can come back over here and say app dot configure API, like so. And we have to add a using statement using minimal API demo. So by registering this, and then now we just say configure API. So we have use HTTPS redirection, configure API, and run. This down here is more the pattern I like to see in my program.cs files, which is that it's essentially a quarterback method. If you're familiar with American football, then the quarterback is the person that calls the plays, executes the plays, and tells things where to go and so on. So with this, it's saying do this, then do this, then do this. It's not actually doing the work. It's just telling somebody else to do the work. It's a manager. And it is managing every step, and it's very clear what each step is. When you get into stuff like this, I'm not as big a fan because it's doing the work. And as a manager, you want it to be managing the process, not also being a hands-on manager. So not a huge fan. I'll probably end up moving these out into their own service file, but for now, we're going to leave that one alone. We'll just concentrate on the endpoints themselves, which are all going to be in here and make things a little bit easier. Okay, so now we need to start creating our endpoints. This is where it gets fun. We could do it inline, but I'm not going to do it inline. I'm going to create a separate method for each one of them. That way, again, it separates out our logic from the call or the configuration, the wiring up of our endpoints. So I'll create one and you'll see how it's going to work. So private static async, because it's an asynchronous method, and we have to add a, not sure why it's yelling at me yet. We'll wait for that. Async task of iResult and get users. iUser data. So this method right here is actually going to ask the dependency injection system for iUser data. Remember that iUser data is this right here, which gives us our 5 methods. So it's going to ask for that, and this method is going to be called get users, which gets all the users. Let's wrap this in a try catch. Now, we're not going to do much with the exceptions here, except we're going to say return results dot problem ex dot message. So we're going to say, hey, it didn't work. Here's the reason why, and throw that message back to them. So get an error message properly formatted in the right error code and so on. But this try catch, we're going to say return results.ok await data.get users. That is our entire endpoint for getting all the users in the database. It essentially comes down to one line. This right here, return results.ok. What this is wrapping the results in a HTTP message of 200 saying success. You don't have to do this. You could return just the actual results, in which case change your return type. But by saying iResult, we're able to wrap all of our things with the proper HTTP codes. That way we can be more specific as to why things don't work or why they don't have access to them and so on. So the OK result says success. Now, I'm returning that right away, but if something were to happen in here where it crashes, we follow the exception and return a problem that gives us our our message as well. So that's how we're going to handle the error codes to properly give back a return. If you want to really cut this down, you could just say await data.getUsers and just have that as your endpoint. But again, you're missing some of the nuances of properly returning codes. And also you can do logging in this catch and so on. So this sets us up for success in the short term and also the long term. It's the way to start small and yet have it be expandable for what you need in the future. So I recommend this pattern over just a one-liner like returning that. So with that, up here, we can say app.map_get, and we'll say /users, notice the plural there, and get users. So that's now our endpoint mapping. We're going to say, hey, I want you to say /users. When you do, we're going to call the getUsers method, which does this call right here. It talks to our database. That's the entire talk to our database, is just, hey, go ahead and do it. That's it. So again, no SQL knowledge here. It does not know we're talking to SQL. It does not know we're talking to anything. It just knows I need users. I'm going to await the result of those users. And if we have success, we're going to return an OK message with those users attached. And if not, we'll throw a problem, or we'll return a problem with that error message. So that's our first endpoint. Ready for the second one? The second one actually has some parameters to it. Private, static, async, task of iResult, get user, int ID, and iUser data. Now, in this case, we're asking for two different pieces of information. And I love the simplicity here because this iUser data comes from dependency injection, whereas this int ID comes from the user, comes from the call to the API. So it's mixing where it's getting the information from flawlessly. So we have asked the user for the ID. We're getting this from dependency injection. And now we can essentially we can just copy this and paste it down here. And we can modify this so that we actually have our proper call. So we got the return result.problem stays the same. But here we can say var results equals await data.getUser, passing in the ID. And then if results equals null, I'm going to do this in one line just to kind of stay in character with the really thin wrapper. Return results dot not found. Again, returning an error message that is really simple. Okay, so that error message is really simple, just not found, but it's going to return the correct HTTP response code for not found. And then return results.OK results. 3 lines that will, first of all, get the results from the user, make sure that they're not null, and return not null if not found, and then return OK with the results if they are found. Yes, we collapse all this down into one line of C# code. I think that's a little too much collapsing for us, but I think this right here gives us the right amount of simplicity while not being so simple it's actually confusing, or so simple it's got too many lines of code that are unnecessary. So that's now our get user, which means we can come back up to the top and say app.map_get /users/curly braces ID. And that will get the ID right from the URL and get user. And now we've mapped our second endpoint, this one asking for information from the user, and based upon that, we'll return back one record based upon their ID, or no records if nothing was found. So that's now our second endpoint. We'll just keep going. So, and notice, by the way, these are private, which means the only thing being exposed from this API static class is configure API. That's it. Even though we're using these private methods and mapping them onto our endpoints, we're only ever exposing configure API. That's it to our callers. So over here, when we say configure API, that's the only thing we have here in our configure API on our app. So, and yes, we are using this as an extension method. That's why this is in front of it. We're adding that onto the web application type. That way we can extend that and add it onto our options for app. So with that, let's come back down here for our insert. Private, static, async, task of iResult. Insert user, one word, and user model user. Notice that's coming from the global using, so it knows where that is, and then user data. Inside of insert user, we will, let's do our try catch again here. It's the same try catch except for the what's in the try itself. So await data.insert user. Return results dot okay. That's it. Okay, we have essentially done it in one line, which is just insert the user and then return okay. And if anything were to happen, we drop down to our exception. Now let's keep going. We'll keep working on our methods, and we'll go back up and map all of these. So let's stick with the pattern here, and private, static, async, task of iResult. And we're going to say update user. User model, user, and user data. And we'll paste in our try catch. We're going to say await data.update user. Return results dot okay. So again, all we say is update user. It's one line, and then we say okay if that succeeds, and if not, we return our exception. So last one, private, static, async, task of iResult, delete user, int ID, and we're also going to have a user data. So pass in the ID, and we're again paste in our try catch. We'll redo this to say await data.delete user, passing in the ID, and then we'll say return results.okay. Notice it keeps learning what I'm doing and get a little better each time at giving me the full line completions. So really cool stuff in IntelliCode there. That's our delete user. And so that's all of our methods are done now. And we're passing in the full user model we get from the user. So this user model comes from the user in our body, whereas up here, let's see, in our get user, we have it coming from the, right here. We're passing it in through the command line, or not command line, URL. We're passing in the ID. And that'll work for get, but we don't want to do that for other things like update or insert, update, or delete. So we'll pass it in through the body. And yet it's still in that same parameter list. It still figures that out, understands it, and properly processes that information. So really cool stuff there that is really, really intelligent. There's a lot of intelligence behind this that makes it look so simple. So we now have all of our calls. We just need to map them. So let's start doing that. App.mapPost, that would be for our insert. So /users, that's it. And then insert user. So again, the different verbs for HTTP, we have our get, which is for reading data, our post, which is for inserting data. Then we'll have app.mapPut users. And then, update users, update user. And then app.mapDelete. And again, users, delete user. So that's our entire set of mappings for our endpoints. We have 5. We have 2 read actions, a read all, which is the first one, get users. Then we have a read one, which we pass in the ID on the URL for that. And then we have these 3, which are post, put, and delete. And these are our insert actions. These are our actions where we're sending data to SQL as opposed to, or to the API, as opposed to getting it back out. Now, you may notice that the path for all of these is /users. And the only one that's different is this one where it asks for the specific ID. The reason why is because we're using different verbs. So get versus post versus put versus delete. This is the way to do a REST API in a way that is calling the proper noun or proper actions for an API. So when you delete a record, you should be calling the delete type, not just a post. Now, if you get lazy, you could call post, but the nice thing is by calling these different verbs that you can use the same path /users and just use the different verbs to indicate what you want done. Now, again, we're not telling these 3, hey, you need to have that model inside of your body. But yet down here, like an insert user, we're getting that model. And update user, we're getting that model. And delete user, we're getting that ID, which is in the body. So it handles that mapping for us without us having to explicitly say where things are at. And guess what? We're done. So if we run this, we should see our application up and running. Hopefully it's going to pop up on the screen. We'll see. Hey, there we go. And now look at our minimal API demo. It actually has 5 different actions on the screen for us. We have our get, post, put, delete, and another get. Let's start with our get here, because we just hit try out and hit execute. And if it works, which it did, that's awesome, first time working, we get a 200 response back saying yes, success. And then we get 4 individual objects back. We've got Tim Corey, the ID of 1, then Sue Storm, ID of 2, John Smith with 3, and Mary Jones with 4. So our get all works. Now, if we come down to our other get, when we say try it out, we have to fill in the ID. Now remember, Tim is 1, Sue is 2, I forget 3 and 4. Let's find out what number 3 is. So we put number 3 in the ID field and hit execute. And we also have a 200 down here, so we are successful. And then we can zoom in here and see the ID of 3 is John Smith. We go, okay, let's find out what 4 is. We come up here and change that to 4, execute again, and then come down here, we see that 4 is Mary Jones. So this allows us to try out our API and allows us to see what the structure is for what is required. So this can really help. Swagger can be really helpful for just visually looking at our API, but it also allows us to build out actual C# endpoints to talk to this API using the Swagger information. So really powerful stuff here. But then let's try the other ones to make sure they work. So post, let's try it out. And it says, and this is the intelligence here again, it says, hey, you need to send back this information, ID, first and last name. Now ID is 0, we'll leave that alone, but let's go with a first name of Karen and last name of Dior. I don't know. There we go. So we now have a new record we want to insert. We're going to hit execute. We'll come down here and we see that we have a 200 response, which means success, but nothing else, just success. So how do you know if it worked besides that message? We come back up to get all users. We say execute, and we come down here and see that Karen is now number 5. So we have a new user, number 5. Now we can do a put. So we can try it out. And the put is for our updating of the record. So let's zoom in here. We have to change this ID to be whatever ID we're modifying. Let's change it to 5. We'll keep Karen as the first name, and the last name is, well, it's actually Smith. Okay, so we got the last name wrong. We change that. We hit execute. We come down here and we see again success. How do you know it's successful? Come back to our get all, execute again, scroll down. We can now see that Karen's last name is Smith. So we've now done an update. And let's collapse that down. We'll do a delete and we'll get rid of poor Karen. So we'll put 5 in there and hit execute. And we have a 200 success on that. Again, let's prove that by coming back up to our get all, hitting execute again, and noting we now have 1 through 4 and number 5 is missing. So our API is fully working in our setup. So we didn't have to do a ton of coding today, even though, yes, there are some complexities in knowing how to put things in different spots, but the actual work was all done in the previous lesson when we set up our data access, which, by the way, remember that data access will work with any user interface except for WebAssembly, but we can hook that up to any UI project, so WPF or WinForms or Razor Pages, MVC, console application, a worker service, all that good stuff. It can talk to any of them. But in our case, we hooked up a minimal API, and then this minimal API really is minimal. So we have our program.cs, which we have 2 services we've registered. We have 1 line here that says configure API. We have modifier app settings to add that 1 connection string. And then in here, we have our global usings just to make things easier. And we have our API.cs. And this API.cs has 1 method that's public, and that just maps our 5 endpoints. Our actual endpoints are super simple. They essentially have 1 to 2 lines of 1 to 3 lines per entry, but then we wrap that in try catch to be good citizens and return the right error codes if necessary, return the OK properly if we get the right values back, and so on. So we've created a full API that talks to an actual database, that gets actual information in and out, and yet it's a very, very minimal setup. So this is what a minimal API would look like. Now you may have a little bit more code here where you might wrap or add logging, or you might add a couple other things. But if you're doing any kind of real coding where there is more work in this try section than maybe 2 lines of code or 3 lines of code, then I would highly recommend you put that in your business logic section, not in your API, and then just call that 1 method. Move as much as possible into your class library so that other projects can take advantage of it, and so you keep your user interface as slim as possible. So that's it. That's a minimal API. That's what I recommend. Now, a minimal API, when would you use this? So we've talked about it before, but I want to kind of cover this, that minimal APIs are really helpful for things like microservices, where you need to do a little bit of work and it's a little bit beyond what an Azure function can do, where you have to have more than one endpoint. Well, in that case, you can create a minimal API and in just a few lines of code. I mean, this is the biggest section right here. Most of it's boilerplate, but we have 79 lines of code. And that's the biggest section of our API endpoint, and yet we have full CRUD access against the database. So yes, one table. So you'd have a lot more if you had multiple tables, but at that point, you're getting beyond what a microservice is doing. So for microservices, this is really helpful because you don't have to have a lot of setup stuff. You can really template this and not even change program.cs, just modify the this section right here and the methods that it calls, and that'd be it. And you could have multiple APIs you can support really, really quickly, and yet they'd be focused in on one microservice and servicing that one microservice properly. So that's a great place to use it. But even just having a small API, this is the way to start, I think. I would start with the endpoints and figure out if you need to expand to controllers. I'm thinking for a lot of cases, you probably won't need to expand to controllers. If you need to, not a problem. You can definitely do that right in your API, right in this API. You don't have to do a new project. You can expand to controllers, not just endpoints. But if you start small like this and work very hard to keep things lean, I think you'll find that your user interface portion, the API, will stay pretty lean and pretty small. And that's a good thing. You don't want your API to be massive. You want it to be lean. You want it to push everything down to your class library and let the class library handle all the heavy lifting. That way you can easily swap it out later. You can put other things against that class library, not just your API, and so on. So I think this is a great addition as an option, and it makes things a little bit cleaner, a lot cleaner, and a lot simpler, and removes a lot of the boilerplate stuff we just don't need in most circumstances. So that is part 2 of wiring up the minimal API. This project is a full project. I mean, it talks from database all the way through the API and back. But at the same time, there's not a ton here because we do want to keep it as lean as possible. Thanks for watching. If you have any questions or comments or thoughts, post them down below in the comments. I'd love to hear it. And as always, I am Tim Corey.